few weeks ago, I made a video exploring 5 actions you can take to transition from a beginner to an intermediate programmer. One of these actions involved getting into the practice of debugging code. So in this video, we're going to take this broken snake game and use the debugging options in Visual Studio Code to fix it. Now, the great thing about this process is you can debug any program you like in the programming language you're trying to learn. But to create these programs in the first place, we're going to utilize ChatGPT and its tendency to create erroneous code when prompted to create programs above a certain size. So to get started, I'm first going to set up my workspace in VS Code by clicking on File, Open Folder, and navigating to the address where I'm going to store this project. I do trust the author because I am the author and the folder is empty. Next, we're going to create a new Python file by clicking on the new file icon here. Now it's time to create a virtual environment to keep our project and all its dependencies self-contained. If you've never set up a virtual environment before, I have a video showing how to do this on all major operating systems. So click on the Terminal drop-down menu and select New Terminal. From here, I'm going to navigate to the folder that contains all my virtual environments, copy the address, and then we're going to change the directory into this virtual environments folder in the terminal. Now, I've created 8 separate virtual environments in the past for various projects, and we're going to create a new one now for this snake game. For Windows, we do this by typing python-m venv and then the name of that virtual environment. If you're using Linux or a Mac, you need to change Python to Python 3. After hitting enter, we have our new virtual environment. We need to let VS Code know that we want to use this virtual environment going forward. So we click on our Python interpreter in the status bar here, then click on Enter Interpreter Path. We navigate to our newly created virtual environment folder, open up the Scripts folder and select New Python Interpreter within this virtual environment. And in the status bar, we should now see the name of our virtual environment. Next, we want to import the Pygame module, and to do this, we'll need to pip install it. And also note that because we are now within our virtual environment, Pygame will only be installed here, and it will not be available system-wide. So let's open up a terminal again. A pip list will show that we've only got 2 packages installed. These are default packages that come with every virtual environment, and a pip install Pygame will download the latest stable release. Okay, so now we're all set up with our libraries. The next step is to get ChatGPT to write us a buggy program. Copying over the generated code to our main Python file, we can now attempt to run the code. As you can see here, we get something called an index error on line 78, and this normally occurs when you try and access an element outside the bounds of an array. For example, if we have this simple list containing 3 elements, and we try and access an element at index 3, we would get a list index out of range error. This is because Python uses zero-based indexing for lists, and therefore we only have indices of 0, 1, and 2 here. Our Python code is a bit more complicated, so we'll need to trace through this code in more detail, and we'll do this shortly. So the first thing I would do is skim through the code in the same order as the interpreter. The point here is to get an overall view of what the program is doing and see if anything odd stands out. At the top here, our code is initializing Pygame, which should be done before any Pygame module is called. Then some constants are declared for screen dimensions and colors. Now we come to the snake's initial position, which is represented by a 2D list. What I believe ChatGPT was trying to do here is initialize the snake with 3 segments at these x and y coordinates, where this inner list represents the x and y location of the head of the snake, and the last list is the current tail of the snake. As the snake grows, more lists will be appended to the end. The snake's initial direction is pointing right, which means we can confirm that this inner list element is in fact the position of the head of the snake. Now a random location for the apple is decided. A randrange function selects a number between 1 and 64 or 48, and this value depends on the current screen width and height. If we later decide to change the values of the width and height, this floor operator will make sure that our upper limit is rounded down to the nearest 10. and this will mean that the snake's food will always align with the snake's head. We multiply the final random numbers by 10 so we can obtain the pixel value rather than just the column and row value. And here, we make sure the food is spawned as the game starts. We have some more Pygame boilerplate code here. Now this game over variable and not operator could be written more cleanly. We could instead change the variable name to game running, set it to true, and then remove the not operator in the while loop expression. The while loop will still execute until the variable is set to false, but it just makes the code easier to read. But I'll revert this for now and change it later. The next section reads in the values of the keyboard arrow keys and ensures the snake cannot reverse direction. For example, if it's moving right, it cannot suddenly move left. Now we come to a number of conditional statements that attempt to increase or decrease the coordinates of the snake's head by a value of 10 pixels. So if the snake is moving up the screen, we take the second element of the first list and decrement its value by 10 pixels. But the issue here is that the rest of the body and the tail are ignored, and this will result in only the snake's head moving about the screen. This is also the line where we encounter our index error. The error doesn't seem obvious here, but when we debug our code in a minute, we will see why the snake position list is causing problems. The next couple of sections involve ending the game if the snake tries to move outside the bounds of the screen, or if the snake head collides with some part of its body. And on line 93, the pop method seems to remove the tail section of the snake if the head hasn't collided with the food during this time step. So effectively, the snake shrinks if it doesn't eat food. After 3 iterations of the while loop, this will mean that the snake position list will have no more elements left, and trying to assign a value to element 0 will lead to an index error because index 0 does not exist. We'll see this in action shortly when we debug this code. And the very last thing I'm going to mention is the reuse of this code here, which is a copy of the code on line 27. We could place this code within a function and just call the function whenever we need it. Okay, so going through the code, we can see a number of odd things occurring, which we'll fix in a minute. But now, we're going to use VS Code's debugging feature to explore our index error in a bit more depth. If we go to the line that seems to be causing us trouble, we can place a breakpoint in the left gutter here by either using our mouse pointer or by placing our cursor on line 80 and pressing F9. You can also select the Run drop-down menu and choose even more options, but that's something I'll leave for a later video. Now we need to select the Run and Debug icon in the activity bar on the left-hand side, and then click on the Run and Debug button. As soon as we do this, our interpreter will execute each line of code until it hits the breakpoint we created on line 80. From here, the program pauses and we can cycle through each line step by step using the debug toolbar at the top here. On the left-hand side, we have the variables section, which displays all the local and global variables along with their current values. And what we can do here is right-click on the ones that we feel might be useful to watch or might directly affect our program bug and click on Add to Watch. This will then add them to the watch area where we can drag the most important variables to the top of the list. If we go up to the debug toolbar, we can use the step over feature or press F10 to execute the next method as a single command. Effectively, it will execute the line we're currently on and jump to the next line before pausing. If we were executing the game over function call with the step over feature, the debugger will execute everything within the function at once rather than entering into the function and incrementally going through each line in the method. If we want a finer analysis of what the code is doing, we would need to use the step into feature or press F11. This will enter into the next method and follow its execution line by line. By pressing the step over feature, we can see that no errors occur when line 80 is executed, but we do see that the snake's head position has been incremented by a value of 10, or in other words, by the snake's size. In fact, we can now add a new expression to our watch list by clicking on the plus icon and typing the name of the variable we want to have a closer look at. In my case, I want to see what changes are made to the x-coordinate of the snake at each while loop cycle. So I step over a couple more times until we reach this if statement, which is checking if the snake's head is colliding with the apple. Because this isn't the case, the interpreter jumps down to the else statement and pops out one of the list elements in the snake position, effectively cutting off the snake's tail. So we're kind of getting a clue as to why our error is occurring. And the culprit is most likely the pop function on line 93. Let's speed up this process by clicking on the continue button. This will run the code without stopping until it hits our breakpoint on line 80 again. As we keep cycling through this while loop, the snake position list keeps getting smaller until it's empty. Now when line 80 tries to add a value to index 0, we get an index error because this index position doesn't exist anymore. So let's stop our debugger by clicking on the stop button and comment out the else and pop method. If we run our Python script normally now with Ctrl and F5, the snake's head can move around and eat food, but the snake's body is left behind and doesn't grow in size. Now from here, you need to continue this debugging process until you've ironed out all the bugs. I'm not going to show you how to complete this snake game from here because you'll learn far better by giving it a go yourself. But if you want to compare your attempt to mine, you can download the code from my GitHub page. And just to warn you, there's a subtle bug hidden somewhere in the code that ends the game if you change direction too fast. Anyway, thanks again for watching. Do post your comments and questions below and I'll get back to you as soon as possible.